Hello everybody, welcome to lecture 23. This is the final lecture for the semester. This mini lecture, be it as it may, is about integrating everything that you've learned throughout the course, okay? And so you're going to see a lot of these problems on the final exam or on your last homework or whatever it is that we're doing. And it really is about seeing the degree to which you can take what you've learned and apply it to sort of real world problems in a way that you would do if you were doing sort of statistical consulting from people, okay? And so I'm going to show you how these problems work, and then I'm going to show you the way that you're going to solve them and figure them all out, okay? So first you need the practice problems that should be in the course content folder under lecture 23, and then in the other folder where your formula sheets and stuff are, you're going to find this thing that says pick the right statistic PDF, okay? And it's going to be this thing, okay? And so when you look at this, I'm going to show you how we read it in a second, but all the answers for these questions you can figure out if you know how to read this particular document, okay? So we're going to come back to this after we read one of the problems, and I explain to you what you're going to be doing for these types of questions, okay? So go ahead, look at this question, freak out, right? Because you go, oh my God, this is a multiple choice question with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 freaking answers to pick from. That's insane, right? Yeah, it kind of is. But this is sort of the problems that you face when you go out in the real world and you try to do statistics for people, right? They come to you with a problem, and you have to sort of figure out which type of analysis will answer their question in sort of the quickest way, so you don't have to spend your entire life solving these problems for them. And so I'm going to walk through several examples of these, and I'm going to show you how you do this, okay? So one of the things that you should see here, right, is that these are all the tests that we learned over the course of the semester, okay? And you should notice there's a demarcation point here as well. So again, we learned how to do a z-test, we learned a one-sample t-test, the independent groups t-test, the dependent groups t-test, 1 and 2 factor ANOVA. This is the t-test for whether the correlation coefficient is greater than 0, and the chi-square test. These are all A through H, right? These are all significance tests, okay? And then all this stuff down here, the phi coefficient, even though we didn't necessarily learn that one, we learned Kramer's phi. Those are both measures of effect size. They go with the chi-square test. The point biserial is sort of a weird one that we also didn't learn. And we learned eta squared, and we did learn r squared, okay? And your job is going to be to read this thing and first figure out what am I asking you for, okay? So A through H, go ahead and write that those things as they currently are. It won't be this way when you see it because the answers are going to all be jumbled up. But if you sort of remember this, right, A through H as they're currently presented, those are all tests of statistical significance. And those things all tell you the degree to which 2 or more variables are related, right? And down here, these are all measures of effect size. And these measures of effect size from I to M, well, they all tell you how strong the relationship is, okay? So what you're going to do is you're going to read each one of these little paragraphs, and you have to figure out which one is the right statistic. And the first question you should ask yourself is, well, is Dr. Hill asking me for a measure of effect size, or is he asking me for a test of statistical significance? And so you're going to get that type of information from reading the prompt, okay? And once you figure that out, you can rule out like half of the choices, right off the bat. And once you've ruled out half of the choices right off the bat, then you just have to figure out, okay, well, what's my IV, what's my DV, are they dichotomous, categorical, or continuous? And you're going to use that matrix that I showed you on the other sheet to figure out what we're going to do. So let's do this first one together. And we're going to walk through all, I believe, 6 examples that I have here. Yeah, there's 6 examples. And we're going to do all of them together, and then I'll even throw out some sort of thought questions as we go along. So let's do the first one together. This one says, are men more dominant than women? So we went out and we got a random sample of 100 men and 200 women, right? And they're all given a test for dominance, okay? So we have some measure that'll tell you whether someone is either dominant or not dominant, okay? So one of these things is our IV. Which one is it? Gender, right? Because people are male or female, and we're interested in whether they end up being dominant or not dominant. Now you have to consider what kind of variable is this, right, for our dependent variable. Well, you should say, well, that is clearly not continuous, and it's not categorical because there's only 2 levels. It's dichotomous, right? They're either dominant or not dominant. Okay, so you already know what the IV is, and you know what the DV is, and you know their units or scales of measurement. Okay, so that's way back from lecture 2, I think. The questions you need to answer, right? It says, what option would answer the question, how strong is the relationship between gender and dominance? And this is sort of the key part of the question here, okay? You have to say, well, he's asking me how strong that relationship is. So he's asking me not for a test of statistical significance, he's asking me for a measure of effect size, right? And so you know it's going to be one of these things down here. You just have to figure out which one it is, okay? Now, let's see. If we're going to do that, what you should come up with, right, is what? Let's go ahead and look at it, right? So we need to now go to this other sheet. So we're going to make this small for a second, and we're going to bring this guy back up, okay? So here's what I want you to do and understand about this sheet. Each square represents some sort of place where the independent variables, units of or levels of measurement, coincide with the dependent variable one. And in each one of these things, there's two choices, right? There's something that's above the dotted line, and there's something below the dotted line. For all of these things that are above the line, well, those things all have something in common, right? They are all tests of statistical significance. And so here is pointing to the different types of t-tests. Here is pointing to the different types of ANOVA, right? And everything above the line, right, it's addressing whether there is a relationship between the variables in the population. Well, what does that sound like? That is a test of statistical significance. So you first have to decide, is Dr. Hill asking me for a test of statistical significance or a measure of effect size? And if you actually look through, right, what you'll notice is that, guess what? All of these things on the bottom, underneath those dotted lines, those are all measures of effect size. So again, you don't have to remember all these things off the top of your head or remember what goes with what. You have to use information from what you gathered to in the question to answer it. And so how do we do that for this first one, right? Well, we said our independent variable, that was whether they were male or female. And so our independent variable or our predictor variable over here, in this particular case, is dichotomous, okay? Now, what do we do for the dependent variable? Well, we categorized people as being dominant or not dominant. And so it is also dichotomous here. Okay, so the answer to our question is one of these two choices. And which of those two choices depends on whether I asked you, is there a relationship between gender and dominance? Or if I asked you something like, how strong is the relationship between gender and dominance? If I asked you, is there a relationship between those two things, then the answer would be chi-square, because that's what's above the line for the significance test. But that's not what I asked you. I asked you which one of those things would tell you how strong the relationship is. And in this particular case, the answer is the phi coefficient, okay? And so if you go back here to our Word document, the answer should be the phi coefficient. That's what you would put as I. So that's how you do it for this one. Now, again, we didn't have to do it that way, right? Let's go to question 2 here. Question 2, it's the exact same setup, right? So are men more dominant than women? We got 100 men and we got 200 women. And guess what? We gave them a dominance test. And this time, the scores, it's not like it's saying you're dominant or not. We have a full range of scores. And those scores go from 0 to 100 real quick. Okay, yeah, you guys get the reference. Hopefully this won't age terribly in like 10 years when students are still watching this and people will like still know that song. The song's actually kind of old already. And so some of you guys might not get the reference, which makes it even funnier to me. I'm just going to leave this in here. It's that part of the semester, guys. So anyway, we have an independent variable that is dichotomous. We still have men and women, right? And now our our dependent variable rather is no longer dichotomous, it's now continuous. And so I'm asking you, what option would answer the question, is gender related to dominance? And so that's a different question than we asked before, right? We're not asking how strong is that relationship, we're just asking, are they related? And if I'm asking you, are they related, you should say, well, clearly at that point he wants a test of statistical significance. And so we just have to find the right one on our sheet. So if we go back to our sheet, what do we end up with? Okay, well, again, our independent variable is still gender, and it has 2 levels. Our dependent variable is now continuous, okay? And what did Dr. Hill ask us for? Well, in this particular case, Dr. Hill asked us for a test of statistical significance. I asked you how strong that relationship was. No, I didn't, right? I tried to trick you there. I asked you, was there a relationship? And if I asked you, is there a relationship? Okay, you go, well, okay, well, it's going to be on the top and it's going to be a t-test. Well, which type of t-test? Well, these aren't people who are married or people who are the same person, right? Because some of them are men and some of them are women. They're two separate groups. Therefore, the answer for this should be the independent groups t-test. And so if you go back to the document, and we're going to have to do a lot of jumping around because there was no way to make this all work on my screen, this should be C, the independent groups t-test. But that's because I asked you, are they related? Now, had I asked you what option would answer the question is how strongly is gender related to dominance, then for this exact same setup, right, it would no longer be the thing that's on the top, because that would then be asking for the measure of effect size, which would have been the point biserial or R squared, right? So I would want you to put point biserial because that's the big thing that's in this particular cell here, okay? And so that's how you do these things, right? And you can see where I can change all of these different permutations, right? I could give you things that are dichotomous and categorical, right? And then I can ask you for the effect size or the test of statistical significance. And I could basically do all of these particular cells and get this. Now, guess what? That's mean too, but guess what? They don't all have to fit in there. There's a couple of other tests that we learned, the one sample z-test and the one sample t-test. You have to learn to recognize those because they don't fit anywhere in this matrix at all. And so that's why they're stuck down here. So that's how we do the first two, and hopefully you guys sort of got that. Let's do the next one. So that was number 2. Let's do number 3. So a cancer organization has data on a large sample of the American population who have died over the past 20 years. They have information indicating the type of smoking done by each individual, so whether they were a pipe smoker, a cigar smoker, a cigarette smoker, or a non-smoker. And they also have the age of death for each person in their sample. And what they want to know is they want to examine the degree of the relationship between type of smoking and the age of death. What statistic would they use? Okay, well, first, figure out what I'm asking you for. The key phrase that you should have zeroed in on here is the organization wants to know the degree of the relationship. So is that asking, is there a relationship, or is that asking how strong it is? And you should have said, well, that sounds like it's asking how strong the relationship is, right? And so is that a test of statistical significance? Or is that a measure of effect size? In this particular case, it would be a measure of effect size. That's what we're going to look for. So we're going to look for the thing that's below the line when we go back to the other sheet. Now we have to figure out, well, okay, that's great. What do we need it to actually be? Which square do we need to look into? Well, we know that we have a categorical independent variable, right? The people in our study, they differed based on the type of smoker they were, okay? So we have pipe smoker, cigar smoker, cigarette smoker, and non-smoker. So there's 4 groups. Therefore, this is categorical. So our independent variable is going to be categorical. Our dependent variable is going to be age of death. And so age very clearly is continuous. Okay, and then we know that we also now want a test of a measure of effect size, right? Because we want to know how strong that relationship is. So that gives us everything we need to know to go back and apply that and figure out what's the right thing to tell them to use. Okay, so again, our independent variable is categorical, so it's going to be somewhere on this row. Our dependent variable is continuous, right? And so we're going to look in here. And because we wanted the measure of effect size, so we're going to look above the line or we're going to look below the line. Well, again, how strong the relationships are, that's going to be below the line on all of these. Therefore, you want eta squared, which is the measure of effect size for when you do an ANOVA. Now, if I had said which one of those things tells us if there's a relationship between type of smoking and death, age of death rather, then yeah, you would go here. It'd be an ANOVA, and you'd have to say, well, which kind of ANOVA? And we didn't learn the repeated measures ANOVA, so that's not even going to be on here. You can just put an X over that. You are going to say, well, it's a one-factor ANOVA because there's only one independent variable there, right? And so that's how you would do that question. Let's do the next one. This is fun. This is actually the type of thing that you do when you sit down and you consult with people who don't know what they need to do. You basically get paid lots of money to figure this stuff out. So I want you guys to sort of get used to thinking like this and doing this kind of stuff. Question 4. A cancer research organization has data on a large sample of people who happen to be cigarette smokers, okay? So all the people in our sample are going to be cigarette smokers. They know how many cigarettes each person smoked per month on average, and then they also have the age of death for each person in their sample. The organization wants to know whether the number of cigarettes is related to the age of death. Okay, so everybody's a smoker, so, right? So we don't have any groups here. What are our variables, right? Well, one of our variables is the number of cigarettes that people smoked every day, okay? And the other variable is age of death. So we got two variables here, right? So we're clearly doing something, and both of these variables are what? What do we notice about them? Number of cigarettes, that's clearly going to be continuous. People can smoke anywhere from 0 to 1,000 cigarettes, and age is also continuous, okay? And so, so we know both our predictor variable and our outcome variable in this particular case are going to be continuous. And so we did have to figure out, okay, well, what does he want to know? He wants to know what statistic they should use to answer what question. They want to know whether number of cigarettes is related to age of death. So again, they're not asking how strongly related it is or the degree of the relationship or any of those sort of keywords like that makes you think effect size. They're just asking, is there a relationship? Therefore, they want what? They want a test of statistical significance. And so we have to go find the right test of statistical significance. And you guys should be at the point now where if you've learned all this stuff, you shouldn't even need to go look at that sheet. You should just be able to pick that out. But if you can't, let's go to the sheet and see what we would pick. So you don't have to use the sheet if you just sort of know these things, So what do we get? We have continuous here, right? So that's the number of cigarettes that they smoked. Age of death is also continuous. So we got to look and see where these things sort of bisect each other. And right here, we have to say, okay, well, did he want the test of statistical significance or the test of a measure of effect size? And very clearly, I asked for the test of statistical significance. So you're going to pick the t-test for r is greater than 0, right? That was the t-test that we did when we transformed the r into the t. And so in that particular case, what you would pick for this answer on the exam would be G. Easy peasy, right? Now again, if I asked you for, if I said they wanted to know how strong that relationship is, then you would have picked the thing below it, which should have been r or r squared. So you can see how you can rule out half of the questions just by knowing whether or not you're asking for statistical significance or effect size. Let's do number 5. So a teacher sees students straggling into her class at highly diverse times. She secretly records when each person comes into her class. Everyone who arrives before the bell is classified as an early bird, and those who are late are classified as rotten eggs. At the end of the semester, the teacher looks at the grades for each group and wants to determine whether being an early bird versus a rotten egg is related to the grade that each student received. Okay, and we're going to say that by grade we mean the letter grade. Okay, and so what would we put here, right? If this is letter grade. Yeah, because we actually said that right there. She looks at the letter grades of each group. Okay, so we know that we have two groups for our independent variable, right? It's whether they were rotten eggs or early birds, so it's dichotomous. And grades clearly are going to be A, B, C, D, or F. And then she wants to know whether these things are related, right? So it's not saying anything about how strong the relationship is to sort of key you off there. So this is clearly going to be a test of statistical significance. And because it's a test of statistical significance, we just have to say, okay, well, one variable is dichotomous and the other one is categorical. And you should even need your sheet to know that that's going to be a chi-square test. Right, that's going to be H. But if you didn't know that off the top of your head, you could figure it out looking at this sheet. And I'm going to give this to you on the exam or on your homework, right? So this is dichotomous, right? For our predictor variable, this is early bird versus rotten egg. Categorical, that's the grade, whether it was A, B, C, D, or F, right? And I asked you I wanted to know if there is a relationship between those two things, okay? And so is there a relationship? It's the stuff that's above the line, so it's very clearly going to be chi-square. Now, if I said I wanted to know how strong that relationship was, right? Instead of, I wanted to know just is there a relationship, then you would have did Kramer's phi, which is what we learned, or Kramer's V was what we called it when we did it in class. So that's fairly straightforward as well. Let's do the last one, and you guys sort of get the point at this point, hopefully. It's the same setup, right? Except at the end of the semester now, the teacher looks at the numerical grades of each group and wants to determine how strongly being an early bird is related to each grade that the student received, okay? So there's a couple things that are different here, right? The independent variable is still dichotomous, right? It's still early bird versus rotten egg. At the end of the semester, though, I'm not looking at whether you got an A, B, C, D, or F. I'm looking at your numerical grade. So our dependent variable is now going to not be categorical, categorical, it's going to be continuous, okay? So we're going to be in a completely different cell, and you have to see, well, what am I actually asking you for? I'm asking you to determine how strongly being an early bird is related to that, right? So we want to know how strong the relationship is, so that's going to be a measure of effect size, not a test of statistical significance. And so if we come back here, right, we have early bird versus late, right? And we want a continuous DV. And so again, this is going to either be point biserial, which is what I would want you to pick here. I know you could use R squared too. They are basically the same, but I would want you to pick point biserial in that particular case, okay? And I'll make it where both of them end up being right, but don't pick R squared, pick point biserial, because that's the main version. R squared is just a generalization of that we didn't even cover. So pick the first one. Okay. And if you sort of get that, then you sort of understand the types of questions I'm going to do. I could basically take just one of these prompts, right? And I could change different things about it to ask you different stuff, right? I could make this not be dichotomous anymore, right? I can change it to something categorical, or I can change it to something continuous, right? I could take the dependent variable and make it something that's categorical or continuous instead of dichotomous, right? And you can see where I could get a design using this exact same prompt for every single cell. And not only can I go in every single cell, I could then ask you how strong is the relationship between the thing, or is there a relationship between whatever those things end up being. So it's really easy for me to make these questions really different for everybody, right? And I actually do this. I have a version of this with every single permutation of all of these things, okay? And they don't really change. And so you might actually see something that looks exactly like this, except I might not ask you how strong the relationship is. I might ask you for whether or not there is a relationship. So you need to read these things very carefully and approach them very methodically. If you can do that, you'll be in fairly good shape. And again, this is really getting you to integrate all the stuff that you've learned, right? I want you to be able to look at whether something's an independent variable and a dependent variable, decide which one's which. And then I want you to be able to say, okay, well, if that's the case, then here's the analysis I need to do based on the question that I want to answer. And if you can do that, you will be able to go out and make tons of money in the real world, because this is the type of thing that people have data on and they don't know how to do this stuff, and they can't figure out what kind of thing do I need to get to answer this question that I want to answer, and they will pay you tons of money to do it for them. More importantly though, or more proximal to your immediate future, this is what experimental psychology is, okay? When you get to experimental psychology, they're going to basically teach you this stuff, okay? They're going to say, well, which one of these things is the independent variable? They're going to ask you that every single time. Which one's the dependent variable? And you're going to have to figure out which thing you want, and you're going to have to do the test. So you're not going to learn any new statistics when you get to experimental psychology. You're going to basically be doing the ones that I've already taught you. You just have to learn this front end. Well, guess what? I've already been making you do that this entire semester, because I know they're going to try to beat that into you next semester. And so you guys are well ahead of the curve if you can do this, because this is what pretty much every exam question on experimental sort of looks like. It's a little more complex than that because they have a lot more peculiarities and a bunch of other stuff. But if you can do this kind of thing, you're going to hit the ground running fairly quickly when you get to experimental psychology. And that, I believe, is the end. And so if you didn't catch any of that, go back and watch it all. Make sure you can do this, and there'll be lots of chances for you to do this in the homework and on the exam. But, you know, you guys should get the point with all of this. And I think that is everything for the entire course. So wrap this up, get the last homework done. And if you're going to be taking an exam, we'll see you at the exam. See you later.